Design patterns. I believe we have discussed enough about the design pattern. Okay, so there are many kind of design. I won't say that we use a particular design pattern what we are going to discuss very much, but it is it is different. It is different from many perspectives. Visitor design pattern. There are two design patterns. Sometimes when we write a class, then we feel that like class, if we see what is a class, then class is nothing but it's a collection of attribute and operation. I would say rather it's a collection of attributes. If I have three attributes and they vary that value, means the combination of their values what they contain every time. Okay, so they have only one reason to change three attributes. They belong to a class. If all three attributes they start varying completely different the way in a combination they used to vary, then they will not belong to the same class. So in a class, all the attributes they should have only single reason to change. It should be cohesive. Intra-class changes should be kind of cohesive. Whereas now classes are going beyond C++ and Python, and it is coming as classes in machine learning. So there also we are talking. So if you are be with us, if you watch us, then same kind of same nomenclature like class, attribute, operation, we will take you all around the globe. So class, either it is a C++ class, Python class, or it is a machine learning class. Now, if I have a class and I have attributes, then can we kind of add attributes at runtime? When we write class, as we have seen in the design principles, once we are done with writing a class, then it should be closed for any modification. Class must not be modified once it is written. Now, if I need to add attribute at runtime, then we have to go for decorator. That is a structural design pattern. But if we then need to add operations, very kind of critical. If we need to add operations at runtime, then what we need to? Okay, so I have a pre-written C++ class or Python class. Means in Python we can add operation at runtime also, but generally it is not considered as a good coding guideline that you keep adding attribute and operations in any client module or any usable module. So service module which declare and define a class, it should only add the attribute and operations at runtime. Uh, Operations. So things should be done at a kind of structural time only, so that it should follow some design principles. Otherwise, if someone start adding here and there, it would lead to a mess. Okay, so if I am done, I am done with writing a class, then how I can add operations at runtime? Class is completely closed now, and it cannot be. It is not modifiable. It can be extended if I want. So it is open for extensibility, closed for modification. But extensibility is okay, but I need to extend it through a new class. Same class, how I can add new operation. So there we land up in a design pattern called visitor design pattern. Okay, like suppose I have a printer class and it has a print function. When I pass data to a print function, print class simply prints it in the printer. But now I want one fax to be sent also. This is a new operation. Since fax need to be sent through the same softcode data, nothing else is required, but it requires the hardware setup and everything. Printer does not have fax facility. The printer class also does not have fax facility. Now, but I want printer class to be extended so that it should provide fax facility also. So this is where adding a new operation in a class at runtime lined up in behavioral design pattern, visitor design pattern. It is little complex, but The way it is something like it is enthusiastic that, oh, I can add an operation at runtime. So nice. Okay, for that we need to design the a class something little differently. Okay, so we need to provide an extra function called accept, and in the accept we have to accept a extra class that is called visitor class. So I have a class. Inside the class, I have a printer class. Inside the printer class, I have a print function. If I call print function and pass the data, it prints it. Now I have an extra function called accept. Accept has a parameter called visitor pointer. That's it. So accept visitor pointer. Visitor is a class interface. That's it. After that, I can have print whatever functions I can. One extra function accept is required, and that accept function, if someone calls, it would call visitors visit function. So visitor is an extra class. This is my class, printer class. Printer class has set of operations. In operations, we add one more operation called accept. Accept takes a parameter of visitor point. Now visitor is a extra class that provides separate operation. So a visitor class is responsible for provide extra operation at runtime. Visitor class is kind of this class now contains visitor class kind of dependable. Okay, it's not like when many containment we have saw aggregation composition. It depends upon. So, or if we go more tightly, then it is aggregation. So this class, printer class, has a accept function, and in accept function, it takes parameter as visitor pointer. Now, if you call accept and visit against visitor point, if you pass an object, then it calls a visit function of the visitor interface. Okay. Now, visit function is provided by visitor class. Inside the visit function, it takes parameter as whatever whoever calls it. So this is called dual dispatching. Okay. This this is service class. Service class knows a visitor class. It calls visitor in its accept function. Whatever visitor class pointer is passed against that visitor class pointer, it calls a method called visit. In the visit parameter, it passes its own this point. So this is service class has a accept method where visitor pointer is passed. If you call accept method passing the visitor point object against the visitor pointer, it calls a function called visit. This passes its own this pointer as its parameter. So it's a dual dispatching. We are calling visitor class and passing our this. So this once this comes here, then this visitor is open to call this class functions. This is dual dispatching. This we call service class call this visitor class function, passing its own this pointer, and visitor class through this pointer call service class function. So now visitor class visit function is extendable function as we can understand now. So now visitor is a interface pointer. Suppose the visitor is doing faxing. Now I would call against this print class, I would call print. Once it does printing, I would call accept and accept a fax object. Fax object is nothing but it's an object of visitor class. When we say accept fax objects, a visit function would get called and printer passes this pointer. So printer has an accept method. Against accept method, visitor pointer is the parameter. So from outside, we client component calls printer print and then call printer accept. In the printer accept, it passes the new fax object against the visitor pointer. Okay. Now this printer class in accept method calls visit method passing this pointer. Now the fax object visit method is called where the parameter is printer class. So inside the visit method, now I have the object of printer class. Now I can call all the operations, and if it is a friend function, then I can access all the attributes. So, fax has a visit method that is as good as sending the fax. Now, visit method is called against the fax, and it has the printer class with it. So it has attribute and operations of printer class. Then now it can access all the data and it can send the fax. So simple. So we are adding a fax attribute to the printer class through the accept method. With accept a visitor pointer, we pass the fax object, and the accept method calls visitor pointer visit. So visitor pointer object is fax. Inside the visit, it receives the printer's object, and in the visit, it can do whatever it wants, and it has the printer object also. If it is friend, then it can access everything. Otherwise, anyway, it can access all its public attributes. So fax is sent. Now the client component, which is dependent upon the printer component, it calls print, and then it calls accept, passing the fax. It doesn't know what is fax. It just calls fax visit, and inside the fax visit, so it calls fax visit passing its own pointer, and inside the fax visit, then we receive the printer pointer and it does the job. What about now I want email also? So instead of faxing, there is another client. He wants email. Now this is a client object, this is printer object. Now this is visitor interface. From visitor interface we derive fax and email. Client component has printer object, it calls print, it prints. Now against the accept, it passes email object. Accept takes parameter as visitor point. Against the visitor interface, there are two derived classes, fax and email. So client component, when call the printers accept, it can pass any object visitor pointer. So now it is passing email object. Email is an object that derives from the visitor pointer. So client component calls printer component print, so it prints. Then it calls it accept, passing email object against the inside the accept visitor pointer. Now the printer inside the visitor, it calls the visitor visit. So in the visitor interface, we have derived one is fax, and derived one is email. Against email's visit, we receive the pointer of the printer, and it knows that it has to send email. So no code change anywhere. Client code same. Only thing is that it does new of an email visitor. Printer code will never going to change in the future. It is closed for any modification. Client code closed for any modification. If we want email, then it can, wherever the algorithm is, then it can accept against object against function pointer, function parameter, and email is passed, that is called. Visitor interface completely closed for changes, and it is extendable in the derived classes. So only thing is you derive one email from the visitor and write its visit method. Everywhere there is no change. Only change is whatever operations you want, just derive from the visitor and keep extending it. And then you have new operations at runtime. So this is visitor design pattern. Okay, so what is the real life usage? Okay, so if we see the warriors what we have seen in the past, then there used to be a warrior called Changez Khan. Okay, Changez Khan was warrior of Mongolia. So Mongolia is a country in Central Asia, more or less. Okay, and it is near to kind of Siberia. So it interfaces China and Siberia right now. So Mongolia is a country, and there used to be kind of a very historic fighter, Genghis Khan. Genghis Khan never lost any war. So that is the history about the Genghis Khan. a warrior who never lost any war. So one of the reasons that was, it is kind of described against him that whatever the army that enters in the morning, same army someone can see in the evening also. So whatever there is horse loss or camel loss or marching elephant loss or marching soldier loss, all used to be kind of fulfilled at the runtime. So in the morning, if there are 10,000 army, including all the cavalry, in the evening there will be 10,000. Okay. If it has lost 500, then 500 will be replaced at the runtime. Okay. So the enemy, when enemy sees that there is no change in the cavalry, then certainly he will. But this is easy in saying, but difficult in the implementation. Means you are when you are struggling in the war full day, and then you don't eat nothing, and at that time when someone is dying from the army, and then it is getting automatically replaced, and it boosts up your power. So that is amazing. So this is Changez Khan. This was Changez Khan. This is Changez Khan. But it is only possible when we have architecture of interface. When someone is replacing anything, horse cavalry, camel cavalry, elephant marching, or soldier, okay, he should know your all the interfaces. Okay, how a person is fighting. What is the interfaces that person is with its own cavalry, then cavalry interface in the full army. If that person understands the full interface architecture, then only he can replace a kind of new horses. Okay, so now consider is as something like that has to be called at runtime. Okay, so runtime you need operation. Okay, now suppose that there is a kind of a class called Changez Khan Army. Inside Changez Khan Army, now someone sees that one guy, one soldier from the horse cavalry, he is getting down. Now he would call, there is a visitor design pattern. So against the visitor, there is a visit method. Inside the visit method. So visit method can be many. So one visit method for one class, like we had visit method. So visit method in the visitor, and the pointer it was taking was the printer pointer. Now here the visit method can be many, like horse cavalry, camel cavalry, elephant marching, like this. So now someone calls except inside the Changez Khan army and passing the visit. Now the visitor class has derived classes. So one is derived class is a kind of replacement. One derived class is adding army. One class is adding weapons. So there are so many visitor classes. So one visitor class is replacement. So from visitor class we have visit method. So visit camel cavalry pointer, visit horse cavalry pointer, visit elephant marking, visit soldier marking. There are 4 visits which you take 4 different kind of pointers. So against the service class, if I call visitors visit and pass this pointer, it would match the visit function of whatever the class, whoever class calls it, as per the function overload. Now, if someone falls from the horse cavalry, okay, now someone calls except method in the Changez Khan army, except 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 replacement. So from the visitor, there is a class that derives called replacement. So except replacement, against replacement, which is a visitor class, it will call visit, passing this pointer as horse cavalry. Okay, so there are many cavalry, horse cavalry, camel cavalry. So there is a visitor class. Against the visitor class, there are many derived classes. One derived class is replacement. Replacement Replacement realizes all 4 visitors. All 4 visits. One visit is visit horse cavalry. Someone is calling except against the Changez Khan army, and there it is passing horse cavalry. Against the horse cavalry, visit function will get called passing horse cavalry as the pointer. Now, visitor has derived class as replacement. Against the replacement, there are many visit functions. Against the visit function, there is a parameter of type horse cavalry. So that will get called. Now you have horse cavalry, you have widget function called against replacement. So replacement is a kind of PhD, means he knows how to replace something in the cavalry, and then that the widget function that gets called, that widget function is special, okay, for horse cavalry one. So it points exactly in the replacement class and widget function in the horse cavalry. So Changez Khan army has the accept method. Against the accept method, we pass replacement visitor. And now, when we call accept method against replacement visitor, it calls widget function passing horse cavalry. Now, against visitor, we have a derived class called replacement. It has four widget method. One is for camel cavalry, horse cavalry, and then elephant marching, and one soldier marching. So in replacement, the horse cavalry widget function will get called as per the function overloading. And there you have horse cavalry object ready-made in front of you, and you are a specialist in replacement what you want more. Now you can just browse through all the full horse cavalry and see wherever the horses are required, and you can replace. So Changiz Khan was an architect, and he certainly would have followed a visitor design pattern, adding soldiers and many others at runtime. Changez Khan never faced any defeat. So Changez Khan is still there. Please be, you be also always in future. Use visitor design.